Hi there, it's time for our proportions and percent workout number 8. This is a fun one today. Henry bought peanut butter. When he got home, he noticed that the tag said he paid $3.50 for 1.25 pounds of peanut butter. Use the following ratio tables to find the cost for different amounts of peanut butter. I put peanut butter on the top, so if you want to follow along with me, you'll want to put peanut butter on the top, and then I put money on the bottom. You might want to write out in complete words. It really just depends on your teacher's expectations, but for us, and it's hard for me to write with my mouse. All right, so my given ratio is 1.25 pounds. So my pounds is up here, and I'll put my little pound mark here too. Remember we talked about the hashtag. This actually represents pound in science and math. So 1.25 goes here, and then my $3.50 will go right here. So that's my given ratio, and they want to know what's 5 pounds. So the 5 is my target number, and the 5 needs to be up here with the peanut butter because I'm looking for pounds of peanut butter. All right. I'm gonna double my 3.5. So I'm just gonna double it. And that gets me to $7. And if I double $1.25 or 1.25, that gives me 2.5 or 250. So I can get 2.5 pounds for 7. Remember, my target number is 5, and I know that 2.5 is half of 5. So if I can double again, 5 pounds of peanut butter will cost me $14. Please write that proportion. So remember, the proportion would look like this, which is typically how we solve, right? And you would have 1.25 here, and then you would have 3.5 here, and then you would cross multiply and divide to get to 5. And then usually this is where your variable is, right? And you would have multiplied 5 times 3.5, then divided by 1.25. So multiplied and divide with decimals. But yet my answer was just a nice whole number that I was able to get to just by multiplying by 2 twice. Okay, guys? So that's the difference. You can always use this method. It always works. But sometimes, and in fact, more often than not, going straight to the proportion to cross multiply and divide actually is more difficult math than expanding your ratio table. So if I was in class, usually if you see my work and also see my students' work, and your teacher probably has you do this too, when we do proportions, we kind of make a table like this. And we write, pounds of peanut butter here. And then we write the money here in words to keep track. We take our given ratio in the middle. And then I usually just kind of work on both sides of it if I'm trying to get smaller or larger, and see if I find a pattern before I resort to this method. Okay. This method is great when we get to 8th grade or above, because then we have a calculator. And so we're not concerned about that math. But this, I would say, an expanded ratio table in 6th grade is definitely a better way to go. Okay. Let's try number 2. So if you're working by yourself, pause the video. If you're in class, go ahead and have your teacher pause, work this one out, and then come back. And let's check our work, okay? All right. Hopefully you've had time to solve. Pounds of peanut butter and money is here. I'm going to start. I always start with the given ratio, guys, because normally we wouldn't be doing multiple questions on the same amount. Okay, so I always start with what I'm given, because if this was the only question we were given, we would have to use the information that we started with, correct? And I know if I double, I get 2.5 and 7. And if I double again, I got 5 and 14. So because I've done this work in the problem previous to this, I'm able to fill this out faster. But if this was the only problem I was solving, I would have to go through and do that. Well, I'm trying to get to 15 and 30. Well, 15 is half of 30. So if I can get to 15, all I have to do is multiply it by 2 to get to 30. And so I'm at 5, and I know that 3 times 5 gives me 15. And then 3 times 14, well, 3 times 4 gives me 12. And then 3 times 10 gives me 30. And 30 plus 12. No, wait, 5. I'm multiplying by 5, not 3. Y'all got to stop me. 5 times 4 is, oh no, we are multiplying by 3. I'm all confused here. My bad, guys. 3. So that's what's getting us to 15. And so when you add those up, you get 50. Hang on. 42, right? Let's check our math. I'm having what I would call a brain fart. 3 times 10 gives us 30. 3 times 4 gives us 12. And so 3 times 14 is 42. And then we're going to double again to get to 30. And so 30 pounds of peanut butter will cost us $84. Voila. Pretty cool, guys, right? And so we started with those nasty decimals, but those decimals dropped off really quickly. So 15 pounds costs $42 and 30 pounds costs $84. There we go. All right, let's see about 3 and 4. So 3, now we're seeing how much we can buy for $1.75. And here we're seeing how much we can get, how many pounds of peanut butter can we get for $10.50. So that means peanut butter is here. The money is here. Always going to start with my given ratio, guys, because maybe this was the only problem I got. Like so. Oh, wait. 1.25 and 350. Ooh, that was a big zero. Okay. 175. I really know money. I like to play around with money, and I know that 175 is half of 350. Just because half of $3 is $1.50, and then a half of 50 is 25, which would give me $1.75. So I'm just going to cut 1.25 in half. And that is also a benchmark fraction that you might know, or a benchmark decimal. We get 62.625 pounds. Okay. So this one was just a one-stepper. I just divided both numbers by 2. But again, if we think about the proportion, if we were cross-multiplying and dividing, and I'm just going to grab a different pen color and write it here. So here is the proportion, right? If you had written it this way, and we would have been looking for this number right here. And look what you would have done. You would have multiplied 1.25 times 1.75 and then divided by 3.5. Every single operation had 2 decimal places in it. Well, all we did really was divide 1.25 by 2. Okay. So that's what I mean by really, really investigate and look at your numbers critically, because sometimes the numbers look intimidating. They look like large numbers to deal with, but in all reality, they're not. Okay. And that is more often the case than not. I think that a lot of times we make the problem harder than it needs to be because we're not looking for patterns. Okay. And then our last one, if you were doing this on your own, hit pause and work out number 4 and then come back to check your work. If you're in class, have your teacher stop the video. Hopefully you've had time to solve. Peanut butter on top. You would think my writing would get better, but it seems to be getting worse as I go through today. My apologies. Always starting with the given ratio, because I might not have been doing all these tables before, which is 1.25 and 3.5, or $3.50. I am trying to get to $10.50, which is here. So I'm going to double, because I know that takes me to 7 and 2.5 pounds. And then hopefully you notice that 3.5 plus 7 equals 1050. 10.50 or $10.50. So if I added these two columns, then I need to add the corresponding row. 1.25 and 2.5 gives me 3.75 pounds. So again, if I had just written the traditional proportion, I wouldn't have used that column right there. And I would have done 1.25 or 3.5 times 3.75, yada, 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 right? So again, all I did was multiply by 2 and then added 2 numbers. Okay, so please keep that in mind, because had we set up a traditional proportion, which would have been 1.25 over 3.5, and then we would have set that equal to x over 10.5. So by doing it the traditional cross multiplication, or what we call the algorithm, right? You would have multiplied 1.25 times 10.5, then divided by 3.5. So again, multiple decimal places in there that we have to keep track of because it affects our answer. Or we could have just done a ratio table and expanded and added that column in the middle. No method is better than the other. Okay, no method is better than the other. The only reason that we are encouraging this method is that we create the opportunity for far fewer mistakes. When we multiply decimals and divide by decimals, we increase our chances of making small, careless mathematical errors that'll change our answer. And we end up getting it wrong when we knew what we were doing. We just made a careless mistake. Okay. All right, guys. Good work today. Have a great day, and I will see you next time.